Say hi to everybody.
Hi, everybody.
Hey, we didn't know we were live.
I'm Stuart. That's Will.
And so Mohan had a question about the roadmap and what's already done.
Stu?
Tech-wise, I assume? Like, if we're talking about the tech build, we've had our private blockchain in place for about a year now in its current form. So that's deployed with we have a Fortune 100 client. They're actually using it. I think right now they're running a kind of POC setup with 4 nodes, although they've tried bigger clusters. They're still focused mainly on application development. So on our private side, we have the full stack kind of there. And that includes Pact, of course, which has undergone some pretty major iterations in the past 6 months or so. So what our roadmap now really concerns 2 things: Chainweb, moving towards our testnet in the summer, and formal verification for Pact. It's something we've demoed, if you've seen our talks, how you can use our formal verification capability to prove facts about the database, things that can never be violated. We're actually we never publicly released that code. That's going to be coming out in a month or 2. And those are kind of the 2 big things, because formal verification is going to really change the way people think about Pact. And then Chainweb, the testnet rolling out, those are kind of the 2 big milestones. Did I forget anything?
No, there's some ancillary apps that we're going to be focusing on, but I think that we're going to also look for community involvement for those. So, wallet type of stuff, block explorer type of stuff.
Dashboard.
People with experience with the parts that go around a mining client would be, they should reach out.
And just for the people joining us, can you guys give a quick description of each of your roles and who you are in Kadena and what the company does, in case people didn't know already?
Sure. So I'm Will Martino. Role in the company, Stu and I are co-founder, co-CEO, co-CTO, co-everything. Just because, wow, there's so much stuff to do. The stuff that I generally focused on was our distributed systems, so scalability, Chainweb design. I also, for a hot second, learned formal verification to get our proof of concept for Pact up and running. What else do I do? I fly around a lot. I talk to a lot of people. A lot of investor stuff.
So yeah, I'm Stuart Popejoy, co-founder, co-everything. Been more focused on, Pact has needed a lot of work, so I've been, over the past, year or so, I've been a little more heads down in that stuff, but also doing a lot of the legwork to keep our private enterprise stack, our engagements going. We kind of both do everything, but I'm more focused on Pact. Will's more focused on the blockchain networks from a tech point of view. And then recently, we've also been hiring a lot of people and doing a lot of growth, so I've been kind of focusing on keeping that going. Whilst Will goes around and glad hands everybody.
All right, we have a question from BTC Trader about the Pact private ledger side and how you handle the inevitable comparisons to Hyperledger. So he wants a quick and dry pitch about Hyperledger.
Sure, happy to take that one. Our client is working towards a consortia use case, and so they directed us to put together some materials to talk about Hyperledger. So we did a deep dive into their technology. Few quick notes about Hyperledger. It's not a blockchain. It's not remotely a blockchain. The smart contract infrastructure they use is non-deterministic. By that, Pact, much like Solidity, Pact is purpose-built for a blockchain, and it's deterministic, which means it can't do things like I/O. Contracts in Hyperledger are written in Go. I think they're going to support JavaScript as well. And this necessarily means that they can't trust the execution of those contracts, so they move trust into the network to run the contracts over a simulated environment and then have processes be signing execution results. I mean, this is not anything like blockchain I've heard, where you actually have a computer program signing something. And those are actually the signatures that go into consensus and are used to determine if something is valid. The user signature, which is the cornerstone of Bitcoin, of Ethereum, of our network, that the trust is outside of the system. It's what we mean when we talk about trustless blockchain. Is completely discarded in Hyperledger. And then even worse, the result of that is not the code you executed, it's just a database read-write set. So they've basically created a database replication kind of backend. They put some hashes around it, make it look kind of blockchain-y, and then replicate those things with these validator signatures. And on top of all this, it's unbelievably slow. It could, one, they won't even tell you performance numbers, and if you try to go onto their mailing list and talk about these things, good luck. But the point is that the highest possible number, and I think this is with a very dodgy test they've ever been able to talk about, is something in the low thousands of transactions per second. So to contrast with us, deterministic, trustless blockchain. It doesn't matter if it's private. It doesn't matter if it's public. Our private consensus is what most private consensuses are. Where you have the nodes identifying themselves with a public key and reaching Byzantine fault-tolerant consensus. But after that, any application level signatures come from the outside necessarily. On the sign, just like Bitcoin, just like Ethereum, and we replicate those just like any other blockchain does. We're a deterministic smart contract language, which means, much like Ethereum, everything executes the same on every single node. So it's really a clear choice. Do you want a blockchain or not? If you want a blockchain, use our stuff. If you want whatever IBM calls its stuff, use IBM. But for our clients, it's a really clear choice.
Question from SpecRed about governance. Does Kadena want to follow the same governance model as Bitcoin with larger mining pools? How do we protect against centralization and the debates that have risen around Bitcoin and Bitcoin Cash?
So, I think that the governance is going to end up being somewhere in between what you see with Ethereum and what you see with Bitcoin, where, Kadena is going to have soft power and going to have influence, but it's still a ownerless network. The people who participate in it are the only owners to it. While we can have, more influence than we would otherwise have over changes to it, we can't make it happen. We can't shut it down. It's just not how this type of thing works. We put it out there and then it's just a new piece of infrastructure. The nice part of how Chainweb works is I think it aligns a lot of goals, or a lot of it aligns the incentives of a lot of people that traditionally don't have the most aligned incentives. I mean, miners want to have higher and higher utility for the network, because the higher the utility, the better it, the more adoption that you get, just the better, their the value that they provide to the system increases. So, with Chainweb, let's say we're running it at 1,000 transactions per second configuration, and it ends up on average using something like 500 transactions a second globally. The miners, the people who are using it definitely want more throughput, because you're just going to want it. You don't want it to get clogged. You don't want to have to start paying congestion fees like you see in Bitcoin and like you see in Ethereum. And so what you end up having, what ends up happening is the miners can look at this and say, well, we can fork to a larger configuration. And also Kadena would be like, hey, we should really think about forking to a larger configuration. And the added cost for everyone involved is, relatively speaking, very small, because the energy used for mining is vastly dominates everything. Like it's 95 or 99% of the costs of operating one of these systems. So, making there be more nodes, so long as you can keep the hash rate the same, which what Chainweb does, you can just increase the number. You can just increase the throughput. So how is it going to work out? I think that there's actually going to be a third participant in how the governance works in this. So there's basically the users and the miners. Or there's the users who are sort of like there's going to be a fourth added to the third. So there's the devs, the users, the miners right now, and I think that the added one are actually going to be businesses that are operating on the platform. Right now, the value of Bitcoin is provided by the network's existence, and that gives the miners a lot of power. I think that with our system, after a year or two, we're going to start to see this incentivized data API ecosystem buildup, which looks sort of like Lambda plus PayPal sort of fused into one. And the people who are providing that, those businesses, that API, they're actually creating a lot of value. I don't like to say that the business is the ones that create value, but sort of going to work that way in the system. And I think that they're going to also have a lot of influence. They're going to say, we really need this added to Pact because we want to do this type of thing. And because Pact's interpreted, we can actually upgrade it. The miners will say, well, that's, the miners will be able to look at it and say, well, this will actually increase the utility of the platform, which is in my interest as well.
Okay, another question about different chains. So they reference Cosmo and Polkadot want to incorporate private and public on the same chain. So why is there a separation in Kadena between public and private?
I think the student or both can handle this. I'll begin. So public and private demand antithetical consensus models. Public needs to be open. Anyone needs to be able to participate in consensus at any time. Whether or not you do is a different question, but that's what mining gives you. This thing where anyone can jump in and participate in consensus. Private is the exact opposite. You want to only have people participating in consensus, actually providing the network that basically everyone else in the network has signed off on. These are different things. Think of it more like point-to-point routing versus Ethernet. While the language on top, so TCP/IP is what we call it. So we have in this metaphor for our system it would be Pact. The language should be common between them, but the two systems are fundamentally different, and you can't connect them. One of the big reasons that you can't is because you can't hoist the assurance that comes from private deterministic consensus and bring it anywhere else. Because you can always, the proof that you actually transport, you can always fake. If I go and I make a Merkle proof for you for a private blockchain that has deterministic consensus, and I go and make this Merkle proof, you have no way of knowing whether or not it's actually real. Because I could have gone and lit up an entire shadow network, done a bunch of stuff to make it look right, but owned all the keys, and then just made this proof and handed it to you. So there's just so much extra trust. So the way that you link these things are through oracles, but it's no longer trustless. And then at that point, while you can talk about how you combine public and private into this one massive network and everything's amazing and whatever. No, it's an API that goes across, and there's some trust there, and that's okay, and it's interesting. But these things are separate until you want to connect them, and the way that you connect them is an API. We've been doing this for 20, 30 years now.
The only thing I'd add to that is to say that Polkadot and Cosmos and even like Lightning Network and some of these things use various structures like atomic swaps and things like that to be able to kind of move things across chains, and Polkadot being fundamentally a hybrid network. So Polkadot is a multi-chain kind of environment, which is not what Chainweb is. So Chainweb is a homogeneous chain. Like all the chains are homogeneous in terms of how they operate. They have separate kind of unbound transactions. The transactions don't depend on each other strictly, but they're all the same execution model, just made embarrassingly parallel and with tons of throughput. So it's a very different architecture, and it is homogeneous. So Polkadot is a very kind of ambitious project. Is just for example is something where and also a lot of the ways they're starting to talk about Ethereum sharding. A lot of these things are starting to talk about kind of like trying to get away from this notion of a mainnet, but they kind of can't. Like if you look at something like Ethereum or Lightning Network or a lot of these things, there's still this notion of like a mainnet that is going to lock up resources so that someone else can play around with them. That's not what Chainweb is, for starters. Chainweb, is a actual, burn and create model, which, obviously some other architectures are considering as well. But it's not a hybrid model. And the thing about the hybrid models is that, it gets very complex to start talking about how you can have any kind of trustworthy cross-chain interaction. It's possible. Atomic swaps are an example of that. But it's important to remember that atomic swaps are not beholden to any one architecture. So it's really easy to do like an atomic swap between our two architectures. It would not be hard to construct something. The whole problem you're going to get into, of course, is what Will was talking about, which is that as soon as proof of work is unique in that it is the only consensus architecture that has an exportable proof of, kind of participation. No other architecture can boast that, including proof of stake, because necessarily identity is something that is created within the system and kind of reinforced within the system, and as soon as you move out of that system, it has no meaning anymore. Proof of work is unique in the sense that there's this kind of like indisputable amount of work that went into the hash, and that it's even like there are people who there's I forgot the name of the Bitcoin NX or something that wanted to make it that you could do the hash, but then that would allow you to do more blocks for and while that's an interesting proposal, it necessarily is a lower security guarantee. So we're fairly low level in that sense. Chainweb is a straight proof of work play using SPV to coordinate the chains. It's not, there's not really a lot of magic there. Our private blockchain is a straight private blockchain. Can we use atomic swaps and things like that to coordinate them? Of course. As long as you just remember that if you look at the Lightning Network, the reason why it works is because Litecoin and Bitcoin are both proof of work blockchains. So they're trustworthy in that regard, and they can interoperate with each other. As soon as you move away where one architecture is, proof of stake or Tendermint or private consensus or ours, the trust models are no longer compatible, and the only way in the end you're going to resolve that is through a trusted model. And trusted model is basically someone signs it, and you believe who they say they are, and so that's fine.
A couple questions for Stu about Pact, and we can sort of
Yep.
Go through them quickly. Someone says
We're
that
taking a while.
yeah, it's okay. Pact is I guess we do want Pact to be the standard for smart contract writing. So they asked, is there a benefit for Pact to be compilable into an EVM bytecode? To this person, there is. What would you say to that?
So here's the issue with Pact compiling EVM. For starters, one of Pact's main value prop is being an interpreted language. So I would, right now, Ethereum, on their roadmaps are being very kind of, they're looking to a polyglot future. And, one where you have WASM over here and you have, and I'm not endorsing this, I'm just saying that they're talking about this. And so, what I would see is that there's a Pact runtime. I would put it into that model. Here's the problem with compiling EVM, is that you wouldn't want to compile, so you have two choices. You can compile Pact, and the problem is you lose 90% of the value of Pact at that point. It's important to remember EVM has no ability to discover metadata about a smart contract that's already on there. It's a bunch of binary. That's just all it is. You can say, oh, that was written in Solidity and probably has a Solidity API. But you don't know that, actually, and that's why right now nobody's business model is calling somebody else's smart contract unless it's ERC20. So Pact needs to be interpreted. So that means you write an interpreter in Solidity. Anybody who's done Solidity knows that's going to be the most expensive. It's going to be parsing. It's going to be doing all the work we do in the runtime. It's going to be implementing all the backend stuff. The amount of gas it's going to use is intractable. So the way forward, if that is the polyglot Ethereum, and that could make some sense.
Another quick question about Pact. What does it mean that you can upgrade Pact? How is that updating different from how it's done on Ethereum?
So Ethereum, famously is code is law. You can't upgrade things, although for some reason you can delete them. What does that mean for law? I don't really know. But, so Ethereum, remember, when you talk about upgrading an Ethereum, you're doing some kind of indirection, like a registry or something like that. And a lot of people are doing this. But it's important to remember that's not a built-in feature. That's a practice where you're introducing indirection from your contract so that you can then slot in an upgrade. It's fine, but it's not upgrading. Let's just be clear about that. In Pact, you can directly upgrade your smart contract. The way that's handled is through governance. Governance can be as simple as a multi-sig. It can be as complicated as something where you gather a bunch of votes and then vote on on the transaction upgrade hash. It's also too important to remember that Pact upgrades are not just code upgrades. With the governance, that gives you the ability to directly mutate the internal state of the contract too. So you can do schema migration, which is very, upgrades are rarely just code. They also have to, you also have to change the data sometimes too. So Pact, the way to look at it is you gain the capability through governance to upgrade and to migrate, and then you perform that in a single transaction. And so your governance can take that transaction hash and propose a vote, or and weight that by like stakeholders or whatever you want, or you could just do a straight centralized multi-sig where like 3 out of 5 people have to sign off on the have to sign the transaction that comes in. So it's an open-ended system. Right now, it's just to be completely honest. Right now, what is in production is the is multisig. It's the next version of Pact that will have the full-on, wide-open governance capability.
Also, that question is actually more about how Pact can evolve. I'm reading the Telegram thing. So it's about how Pact can evolve over time and why that's different than Ethereum evolving. So the way that I would respond to that, at least if that was actually what the question is that you can think of it like, because Pact is interpreted and because it's a much higher level language than just Ethereum bytecode, it has standards for what the governance mechanism should do, what the binary representation of stuff is like, not even the binary representation, just like how things are thought of in the key value data store that exists, a bunch of other stuff. So that means that, and also Lisp, legendarily has the least syntax of anything because it's just a bunch of functions. So you end up being in this position where you can go and add new things to the language without breaking old things because let's say we wanted to add, for right now it's key value, but let's say we wanted to have multiple keys. It's almost like a tuple of keys. That is something that we could go and add to the language and still have backwards compatibility for everything else, where you would just end up having sort of like a shim, and it would just sort of be in front. Whereas in Ethereum or in the EVM, you run into this problem where it's like you're trying to upgrade part of your assembly language while code is running on it. And because it's so low level, it totally changes many of the risk profiles, the attack profiles of the code that's already on there. But Pact, by virtue of being much higher level, can be expanded without, and also can be augmented without that change impacting the security profile in basically any way. I mean, yeah, of course we could change plus to be something insane, and then but that doesn't make any sense. For sane things, you can actually do an upgrade because it's interpreted and because it's a much higher level language that assumes a lot more about everything that isn't the actual logic that you are executing.
Okay, so we have a couple questions about our team, like how big it is based on them trying to figure out on the website, and also about our roadmap again. So maybe give a sort of brief rundown again of the roadmap for the next few months and what stage our product is at and who is on our team besides you guys.
You want to roadmap again?
So the roadmap was kind of what I described before. I mean, there's other, once you get outside of tech, there's some other kind of key items in there. To restate that, kind of like our big releases, there will be kind of one thing I didn't say is there will be a kind of chunky Pact release that has some of these more advanced governance features where you're talking about. The formal verification system coming online and being available to use, open sourced and being available to users in the next month or two, testnet in the summer, and then of course public launch at the end of the year. Regarding our team right now, we're 6 people. We just got our first. We just hired a lead engineer, Haskell engineer, so that's somebody who's going to be working on Chainweb and our scalable BFT product. Before that, we engaged 2 developers who were formerly working with JP Morgan on Quorum, and who are incredibly talented language engineers who are actively working on the formal verification solution. That's in tech. We have Ben Jessel, who is our head of growth. He comes from Capco, which is a financial services consultancy, and was involved in basically every major financial POC that has happened in the past year and a half. So tremendously exciting for working on some of our private use cases. Vivian Chen, who's moderating this AMA, joined in January and brings a lot of skills in the area of PR, media, social media, and just kind of messaging in general, and she's been amazing. And then of course Monica Quaintance, who is our first hire. She's an engineer. She is a mathematical contributor to the Chainweb paper. She's also been very involved in our our strategy in terms of how we're going to be building our developer network, and how and setting up meetups and setting up communities and all that kind of stuff. She's also everything involved with what we're doing right now. And then of course we're a small startup, so everyone's kind of doing everything on top of that. Going forward, we have more engineer hires. We have more hires in the business development area, and we have more hires in the community-oriented part of things, so that we can we can stay in touch with the growing body of Pact developers out there. It's going to be a party.
Question for, I guess, Will or Stu. What are your thoughts on tangles like IOTA? Again, another question. And is Kadena a DAG? DAG?
So we're going to skip over IOTA because everyone knows it's BS. Tangles, it's true. They leak the emails. No.
I'm not in.
Oh, sorry.
I don't even know what a freaking tangle is.
Yeah,
Sorry.
Yeah. So we'll talk DAGs. So Chainweb isn't a DAG. So a directed acyclic graph, it has a causally consistent execution model, and the way to think about why Chainweb isn't a DAG is that every single chain in the web has its own genesis block. The genesis blocks are identical except for they have they identify which chain that block is found on. So chain 1's genesis block has a contract in it. The contract says that I am chain 1. And then here are all of the other chains that I think exist. And when you hard fork, that's actually part of what you change when you go to a larger topology, is that it says, okay, now these are all the ones that exist, and these are the ones that I need to directly connect to every time you make a new block. Whereas a DAG starts from one single block and then spans out. So that means that the problems with DAGs are that, and you run into this in trading systems, also I think in databases, it's, causally consistent execution has known problems, but they're sort of rare to run into unless you're in certain fields. And the problem is that, so because you start with one thing and then you're doing a bunch of stuff in parallel, so long as all of us are doing transactions that don't actually need to be ordered very often, you can do them all in parallel. And that's what a DAG gives you. So it allows you to, like EOS does this, Hashgraph does this. So it allows you to have really, really good throughput in the beginning. The problem is, and you run into this in trading systems and other places, that once you have a couple killer apps, so in trading systems this is called the everyone trades Apple problem.
CryptoKitties.
CryptoKitties is a decent example, but let's actually say that like Airbnb, like something, was put onto Hashgraph. And it was, everyone's using Hashgraph. There's like hundreds of thousands of transactions that are all taking place in parallel because they're all basically unrelated to each other, and they're just point to point between people. And then all of a sudden someone actually puts a business onto this thing and actually starts using it for part of their core business flow, and it gets adoption. The problem then becomes that while we're still doing a bunch of point-to-point stuff that doesn't need to be sequentially ordered, the interaction with that business causes the network to no longer be as wide as it used to be, to no longer have as many things that it can do in parallel. It ends up narrowing because you need to start ordering more and more because a quarter of us or half of us that would have been doing these things that they don't need to be ordered very often are now doing things that need to be ordered much more often because we're all interacting with the same thing. So once you get 2 or 3 killer apps, basically like as the thing grows and as it gets more adoption and more usage, it ends up the adoption is actually what ends up slowing it down more and more and more. The graph can't be as wide because things need to be ordered more. So long as you have any centralization of this, like someone puts out a few useful apps, and then all of a sudden you're not running at 100,000 transactions a second in parallel. You're running at like 20 or 30, or maybe 100, maybe 1,000. But it is this core problem that if these things are really long term, the next generation of the economy, and I really do think that they are, that technical path is going to have huge problems because as it gains adoption, it necessarily slows down. There are some tricks you can do, and some people probably point out some subtleties for this, but I would just say, to that, there are other models for execution that work better. Chainweb represents actually one of the ways that you do this in trading strategies, where instead of you having to check against some global, instead of you having to make sure that everything is sort of causally consistent, you do a resource transfer instead, and you make that the expensive part. And that's what we use SPV for in Chainweb. So each chain, if CryptoKitty shows up on one chain, it doesn't affect any of the other ones. That one will just slow down, and then people can either move their funds out, or they can wait for the congestion to go away, or something like that. But one execution thread, effectively, one of the chains getting clogged doesn't affect anything else. So having a killer app doesn't end up slowing down the entire network.
Another question from SpecRat. There's mention in the white paper about chains in Chainweb being built for specific purposes like storage, or application, or high throughput chain. How do you see this working?
This one is something that I'm still playing with, but right now the design of Chainweb is that all of the chains have the same gas model, have the same difficulty, have the same everything. There is a idea that you could actually have specifically a different gas model for certain chains, and you could say that this part of the network execution is twice as expensive, but storage is half as expensive. And if you wanted to deploy a sort of like an S3-like application on the chain, you would deploy it over here for the actual storage of the data, and you would then have either oracles on other chains, sort of like ATM branches, or just draw Merkle proofs back to this thing, like back to this region where it's cheap to store things, but it's expensive to run things. I don't actually know what that does to how the system works. Like, it shouldn't have a material impact, but it's an idea that we've been toying with a lot, of actually having having regions that have tweaks to the model to make them become dedicated. The other thing is that I bet that just longer term you're going to see people localizing regions, localizing around certain regions. So like there'll be an ICO region of the chain, and the specific reason for that will be that the cost of putting a Merkle proof that is from one chain to the entire other side of the network is a little bit greater than the cost of doing two chains that are just right next to each other. It's not a huge amount. I mean, it's like, I think it's a couple hashes. But given that everything costs money in this execution context, I wouldn't be surprised if you see certain regions localizing just to decrease the cost of actually doing cross-chain SPV.
Okay. Let me check for other questions. There's some question about Pact and sort of what, I don't want to focus too much on our competitors, but what is Pact kind of comparable against in the current, is there anything close to Pact in the current state of smart contract languages?
We kind of don't think so, and we always have this attitude about competition that we like it because and by that we mean we like people who are offering things that can be compared to ours, because my metaphor is it's like you open up a restaurant, you want another restaurant to open up on the block so that people are actually coming to eat dinner there. So you should welcome competition, not fear it. Having said that, it's been a little disappointing. So for instance, so much development has focused on kind of VM-based architectures, or the EVM itself. There's a lot of reasons why the EVM architecture is not ideal. But I think the biggest one is that I think they kind of didn't get why Bitcoin was a bytecode. The reason why Bitcoin was a bytecode was not for low-level goodness. It was they wanted a really tiny language, like just super, super tiny. And that's why it's actually tractable to write in direct bytecode on Bitcoin, is because it's not there because VMs are cool. It's there because they basically didn't want it to do anything except exactly what it's supposed to do, which is it's supposed to basically be a gate that you have to pass through to be able to spend this output. And they wanted flexibility surrounded that, and that's it. Taking that notion of bytecode and turning it into a full-purpose VM is is one where I just lose it. I'm just like, I lost the thread there because it wasn't a general-purpose VM, and now you have this tiny little CPU, which is basically the most unsafe architecture you could ask for. So many other reasons why I think VMs aren't good, but the core one is I just think there's like Bitcoin to Ethereum, that you lost something there. So blockchains architecturally resemble databases. It's just a fact. Pact looks somewhat like a stored procedure language, but most importantly, when you look at it, packet databases, they're all interpreted, with the exception of, I think, MySQL wanting their stored procedures in C. But other than that, the real databases are interpreted, and there's a reason for that. And so I would have expected to see a lot more interpreted smart contract languages. Someone being like, yeah, Pact doesn't have it right. Here's the interpreted language that really does it right. Haven't seen it. All I've seen are new languages that target the EVM because people think the EVM is here to stay and that's the way it's going to go. Or much worse architectures where people want to pretend like you can run a general purpose application language in a blockchain. I mean, it's insane. I mean, why would you think that writing in Java or Go or JavaScript and just chucking that on into a transactional high security environment is going to make sense? It doesn't make sense in databases. Doesn't make sense in blockchain. So I think Pact is very unique in that regard. And Pact is unique as an interpreted language too. I mean, just some of its notions of how exactly it's Turing incomplete, how it admits itself to formal verification. Again, I would love for someone to come along and say, "Oh, you forgot about this." I'd love to see it. I haven't seen interpreted. I haven't really seen the database focus. I haven't seen the focus on public key authorization. That's something that I can't believe is missing from Solidity. It's kind of more native support for working with public key signatures. To me, that's what a blockchain is all about. So,
there's also another part to it, which is that Pact is, because there's like Plutus for Cardano, and there's, I think, Adjoin has a language.
Right, and they compile.
Yeah, and they compile. No, so this is more about the actual targeting of who the language is for. Pact is also, I think, unique in that it's designed not for programmers. It's designed for people who are technically savvy, but aren't necessarily a programmer. And like where I at least personally set that line is recursion, is building up state over a loop, is that sort of thing. Because as a lot of people have seen, there's people on desks at financial shops or just lawyers who are really good with Excel that can build these amazing applications when just given a tool that represents the way that they think about the problem space. And Pact is unique in that regard too, of actually being designed for people who aren't programmers. This means, of course, that it takes about a week for someone who's a programmer to learn the language. Sort of like learning SQL, you can learn it in a second. But it's really designed, think of it like this. So SQL, if you're a developer, you can learn SQL very quickly. If you're a marketer, it takes a little bit of time sometimes, but it's not uncommon to see marketers, advertisers, salespeople learning SQL so that they can actually query the database at the places they work. Pact is designed around that idea, that philosophy too.
Could you go back to the question, because there was a question earlier about Turing incompleteness, because people want to know, our reasoning for why Pact is potentially Turing incomplete.
Yeah, so that's, again, Will kind of touched on it. So first, let's say what Turing complete means with respect to Pact. It means that you can't recur. That means a function can't call itself or call itself via any number of other function calls. You have no unbounded looping, so that's kind of while true, or something for I equals 1, and then it just keeps increasing. We do looping in Pact is done over lists, kind of in the functional style, so map, filter, fold. So you can iterate. It can never be infinite. And then lastly, we don't allow anonymous functions because with an anonymous function, you can create something called a Y Combinator, which simulates or which basically affects recursion. So that's the essence. That's the sum total of Turing incompleteness in Pact. Otherwise, Pact is a full programming language, and it buys us a number of interesting things. First off, one, there is a safety component, as Will was talking about. Recursion is the source of pretty much every nasty bug that has ever plagued programmers, in the sense of really weird things that are really hard to solve and stuff like that, are kind of feedback systems, right? We have a belief that that when you're doing stuff on a blockchain, safety is paramount, and what's more, simplicity is paramount, in the sense that what is a blockchain at the end of the day but a kind of system of record? The real value of this to all of us is the fact that there is state that's being maintained that none of us dispute. So we don't see a big utility for recursive functions in there, even though it might make a few things a little more difficult. That's the price you're going to pay for Turing incompleteness. There are some big benefits, though. It makes Pact faster because we can aggressively inline function references. It's one of the reasons why we have formal verification, is because one of the first things you have to do with a language is completely unwind all your loops and turn them into, in fact, modeling infinite loops is very difficult in formal verification. So, we've reaped and then that inlining contributes to safety. You deploy a smart contract to Pact and you import someone else's smart contract. You import that code when you import, and it never changes. There's a lot of interesting stuff, which I don't think we should go into right now, about what that means for dependency management. But the point is that your imports are also very safe at that point too. And the code is always has a terminating path, which is just much safer.
Question for Will about Chainweb. What are the limiting factors to Chainweb scalability? Is it theoretically infinite?
No, it's not. It's not theoretically. I would go with no because, well, so if you assume that that you can have a diameter of a graph that approaches infinity, then yes, I guess it's theoretically infinite, but then it's not actually useful because you don't actually, nothing ever like is confirmed. So, so no, but it's so, the bounds are, the upper bound on how big it can get is way beyond anything that's ever going to get deployed. We're talking billions and billions of chains, so that's just part of it. Like I can't even imagine what that would look like. It'd be so insane to run like, a billion or trillion transaction per second network. It'd be nuts. So that's on the upper side. The limiting factors, the practical ones are, this thing, you give it bandwidth and it gives you throughput. Or you give it bandwidth and you give it replicating servers and it gives you throughput. So it really, right there, the global bandwidth is probably the limit for how big we're ever going to grow this thing. And even then, I think that you could probably run a million chain network. It'd be expensive, but I think you could probably do it. I don't know why on earth you would want to, but you could. So then on the low end, actually the limiting factor is, I think it's the resolution of how small you can make the difficulty level. Like, so, and the reason being that, because in Chainweb, you take your hash rate and then you, on average, you spread it around the entire network. So if you were to put a million chains there and you only had a hash rate that was equivalent to like, me mining Dogecoin on my computer, you actually couldn't make the difficulty small enough to have that equal. So it wouldn't really work. So effectively, like, if you assume that you have any miners, then that lower bound doesn't apply. Those are the bounds that I've been able to find. The really practical bound it's not a bound so much as it's a trade-off. The degree of the base graph that's used, we need to do simulations for this, but I think that probably around 10 or 15 is going to be as high as you can ever make it before you start having problems. I know that 6 or 8 is going to work, but I just want to see sort of where that bound ends up being. And then so you end up having this trade-off of what the diameter of the graph is, so that's how many blocks in depth you need for something to be confirmed, traded off against the degree of the graph, which is how interconnected it is. And when you pick 2 of these things, then you end up getting the network topology and the actual size of the system. So, there's trade-offs to be made, and the bounds are so ridiculous on either side that we're never going to actually hit them.
This is more of actually a question that I've been having about the centralization. I'm just throwing my own questions now since we're asking them. I've heard a lot of people talk about how both proof of work and proof of stake have their own sort of like centralization problem, one with stakeholders and one with the fact that large mining pools, like there's sort of a tendency towards centralization. Is Kadena doing anything in their protocol to sort of actively work against that, or is that just something we don't expect to happen?
So I would say that centralization at some level, given our current technical capacity, and by that I mean mankind's level of technology, is unavoidable. Either you have, because I don't have the ability to have my phone talk with someone else's phone on the other side of the world without going through something that is centralized. So either you have centralization, at the network layer, or you have centralization at the mining layer, or you have centralization at the identity layer. Proof of work, you end up seeing pools that get formed, so you end up having this sort of centralization at that layer. Proof of stake moves it up one higher. It makes it actually look a lot like JP Morgan, Goldman, Bank of New York, except that it's Vitalik and Gavin Woods and Joe Lubin as like the bank of Gavin Woods and the bank of Joe Lubin, and they're the validators. They also, by the way, are going to be running afoul of money transmitter laws once this thing launches, because they're going to be voting on transactions and deterministically confirming them, and that runs afoul of Title III of the Patriot Act. Yeah, it's going to be interesting. It's going to take a few years for the regulators to figure it out. But for centralization, centralization there are some useful features of it. It allows you to run a very large network with a very high degree of security. So, but one of the interesting parts of Chainweb is that you can actually mine subsets of the network, so long as the overall hash rate is mining, so long as it's like over, I think it's 2/3 of the network is mining the entire network, or 2/3 of the hash rate is working on the entire network and replicating the entire thing. Then that last 1/3, those can be really tiny mining pools. But in any successful cryptocurrency, there's going to be some level of centralization in pools. I think that the key is to align the interests of everyone. So the miners want the network to show more utility, gain more adoption because it's good for them. The businesses on there want to know that the miners are going to have their back and are going to, as this thing gets more and more use, increase the throughput of the network so that they just put a bunch of money into running their business on here and then it will actually continue to work. And then the users want to know that there is a high degree of security in the system, that someone isn't able to really go and do some malicious forks, double spend attacks, that sort of thing. And with Chainweb, it seems to align all of those interests in the right way. It's do you have anything?
The main thing I just want to point out is that Chainweb is interesting in the sense that it promotes certain kinds of coordination. So while the fact that a 1,000-chain Chainweb operation to mine the whole thing is necessarily an kind of capital-intensive thing where you're going to have a bunch of servers, and that seems to favor centralization. The very thing we're talking about, like a business goes on to the platform and wants to run load balance over 10 chains, and then they have an interest in running those full nodes. Maybe they even want to mine. It actually doesn't. There's a way that coordination is encouraged where a large mining pool can interact with a smaller mining pool to take advantage of the fact that smaller mining pool is focused on a certain subset of chains. So that's just a very interesting thing that Chainweb's architecture encourages. So while I'm not sure we can give you a perfect answer that says that centralization is not going to happen, and again, I'm not sure that's something we even want to commit to, one nice thing about Chainweb is that there is a potential for benefit to come from different sized players, and that's not something I've seen from other architectures.
Is there anything that there was a question that's a little bit more going way back in terms, and it's just like what type of proof of work will you be using? So I think that's, if you want to answer that,
Is that just the hash algorithm?
The hashing algorithm. So the hashing algorithm, we have a number of people that we're working with to try to figure out exactly what the right solution for that's going to be. That one, I'm of the opinion that can be a pretty late in the game decision that we should definitely look into, but is something that I want to talk with a few people about what they think and get a bit more of the history, because I have never really mined, so, and I don't have really, really good connections there, although we're building them. Right now we were thinking of Blake 2. It may end up just being that we use what Ethereum and everyone else uses. There's no way that we can get around ASICs. I just wholly don't believe that you can't use it, like make an ASIC for any hashing algorithm. Even if it's memory intensive, it just means that it's harder to do that. So probably something tuned for GPU mining, just because I like the idea, but I don't really know.
Yeah, following up on that whole ASIC resistance thing, what is our stance on ASICs, I guess?
I think it's widely recognized that it's impossible. Ethereum came out originally trying to be ASIC resistant and it didn't work out. So
the way to be ASIC resistant is to have a blockchain that doesn't actually succeed, because then the R&D costs for making the ASIC are higher than the value you get from building the ASIC. So anything that's successful you can build an ASIC for, and once it's successful you have the non-intuition, non-intention, incentive to make one.
Okay.
Blake 2, interestingly enough, Blake 2 is very fast on x86 architectures. So if we go with Blake 2, one of the things that at least out the gate, x86 based architectures will be competitive, but it's just a matter of time. And then someone comes out with the ASIC, and then it's game over for that.
It would be nice to have to pick a hashing algorithm where there are a bunch of ASICs that are available and a bunch of pools that are using different ASICs for the same thing, just so that you don't end up with one person having the only ASICs for a period of time.
Some more questions. How do you envision permissioned and permissionless chains interacting? Aside from solutions like Polkadot, which require something other than a Kadena solution, how does Pact assist in this?
You want to do it?
Pact has, the main thing we kind of talk about with Pact is is Pacts in Pact, which are these, the area of computer science is called coroutines, but they're basically interruptible functions, and we use them to model multi-stage interactions. And they also have an interesting capability regime that you can create, but also it's going to be something we're going to be building into the language shortly, that allows you to kind of have a resource that only exists during that multi-step computation and makes possible interesting possibilities for like trustless escrow and things like that. So Basically interchain operation is a subset of any off-chain interaction, because there's other kind of important off-chain use cases. Say you want to interact with a kind of a non-linear pricing model or something that's going to like compute you a fair value for some stock or something like that. You don't want to do that on chain. There's no reason why. You just want that price and somebody to sign it and say, like, you want Bloomberg to do it, or you want someone to do it and sign it and say, yes, this was from Bloomberg. So when you get sued, you can say, well, they did it, I didn't do it, or you did it. But the point is, off-chain compute is a thing that's always going to be useful. It's always going to be a part of blockchain applications. And so if you think about it, two chains is just a form of off-chain compute. You're basically going to another chain, and you might do some kind of thing where you exchange cryptographic proofs, where Pact will have native support for simple payment verification, i.e. Merkle-based proofs. So that's something that would allow something like a trustless atomic style swap, but based on SPV. We can of course do hash locks. The atomic, a hash time lock, which is what underpins Lightning Network and things like that. To me, it just doesn't seem like a problem that we need to spend a lot of time thinking about, because we already have things like atomic swaps. We already have SPV. It's basically exporting trust from one environment to another. There's a law there that says that there's the proof of work issues, but just in general, it's not just blockchains we're going to be talking to. It's all sorts of systems.
Yeah, we ran into this at when we were at JP, where very serious people would take very seriously the interrupt problem. The interrupt problem isn't a problem. It's just something that's tractable, that people think that they can make progress on, and they can make progress on it because tractable, and it's not actually that hard. I'm sorry, it's just not. You write APIs, you sign things through Oracle services, and if you're proof of work, then you can actually, some of your assurance is pinned to laws of the universe, and if the hash rate's high enough, then you don't actually need to sign that thing. But interrupt between chains, it's just not that difficult. You have SPV, you're signing, and if you have coroutines, then that handles it. You have APIs for the rest of it.
All right, I think that about wraps it up for
Okay.
questions.
Solid.
Any last words if you guys want to say them? That's
Yeah.
it.
We're hiring Haskell devs to work on Pact, to work on the public chain, to work on the private chain, all over the place. If you were interested, reach out. Right now we're focused on building a team out in New York. Longer term we'll probably end up doing some remote stuff, but we're just not there yet because we're still small and we're scaling quickly. I will be in SF next week for Token Fest, and then probably in Hong Kong and Tokyo the beginning of April, the first 2 weeks. We'll send out newsletters and stuff for where we're going to be.
Yeah, sign up for our newsletter. Obviously, you're already on Telegram. Thanks for watching this, and also our open source kind of, right now we have Pact, and we encourage everybody to, dig into the code there or play with Pact as a language itself. If you have feature requests, anything like that, we're always looking for more input. So thanks for watching this.